Hey guys, I'm going to be going over U-Substitution. U-Substitution for me was really difficult for a long time for some reason, and I'm not entirely sure what it was, but something clicked for me this semester and I'm in love with it. So hopefully I can make it click for any of you guys who don't know it, and if not, it's just going to be a good refresher before the exam because U-Substitution is used often. I'm doing one of the problems from WebWork Homework 2. And it's a little bit of a basic problem, but I chose that specifically because I wanted to make it easier to see exactly what's going where. So we've got dy over dx is equal to the natural log of x over x times y. Now the first step is obviously simple enough where we can get all the y's on one side and we can get all the x's on the other side. So we've got y dy. By cross multiplying, we bring the y up to the left side and bring the dx up to the right side. Natural log of x over x dx. Now the y is easy enough to deal with. We see that all the time. We can pretty much just do that in our heads, but having natural log of x over x is not something that we can just take one or two steps to have our solution for, and we want it in terms of another variable that we can simplify. When you go to differentiate, you can make y raised to 1 plus 1 is y squared, divided by 1 plus 1 is 2. And we've still got a complicated term on this side. And this is where we'd want to use U-substitution. Something like differentiating by parts wouldn't be easy here, so we want to try and get this in terms of another variable that will make it simpler for us. And when you do use substitution, the nice thing is you can pretty much ignore the other side of the equation and just focus on getting this down into something that's manageable. And then once you do, you just go right back in and keep going. So that's what we're going to do here is we're looking for u to be the most complicated thing up here, because when you find the derivative of something, you're making it a simpler term essentially. You're taking it down factors of x. So we're looking for the most complicated term here, and the nice thing is this is really easy to see what it is. We've got natural log of x on the top side there, and just a 1 over x on the bottom side. I find a lot of times when I'm dealing with trig problems and stuff, it's not always so obvious as to what the most complicated or more simple one is going to be. And sometimes it can take a couple tries. You can pick one for you and you can try it out and you can see, man, that's not going to eliminate what I need it to. So you can try something else. Every once in a while you won't be able to use u because you've got to be able to also bring in du into the equation. And if you don't have enough x terms out there or whatever variable you're trying to get rid of to bring du in, then you just can't. So we've got here, luckily, nice and simple, the derivative of natural log of x is going to be 1 over x dx. And this is where it got trickiest for me, is trying to figure out how to put that du in there and how to make sure everything is exactly where it needs to be. And I've gotten rid of enough stuff and I've put enough stuff in there. So I know we can all sort of see, oh, we've got a 1 over x here, dx, there it is. But I'm just going to take it one step further. For the more complicated problems in the future, you want to actually figure out what dx is, because you've got to put this directly in there. We've got a natural log of x, so we can 1-to-1 ratio, boom, put a u in there. We don't have 1 over x dx is a bigger term, so we want to take that down a notch to figure out one thing we can just 1-to-1 ratio out there. If we multiply x up to the one side, we've got dx equals x du. So we've got dx in there, we can just plug that right in there, and we'll watch it disappear too. So if we do that, we've got y squared over 2, and we can just continue to ignore that, which is nice. And we're going to have u over x, swap out the natural log of x for u, and we swap out dx for x du. And that guy gets eliminated, and that guy gets eliminated, and it just becomes u times du. Now we've taken complicated thing by putting it in terms of another variable that we can work with and derive on our own and plugging it back in there. We substituted back in u, and now we've got a super simple term which we just did. So that becomes y squared over 2 equals u squared over 2. And we've got our constant we got to deal with, so we're going to put that on this side since this is essentially the x term here. And we see that we've got other constants that are going to get moved around. We've got these 2's here. So we're going to plan ahead and we're going to make c c1 because we can simplify that down into a normal c later once we deal with stuff. Now we've got u equals natural log of x, and we're looking to get this back in terms of x, so super easy, just plug it right back in there. Y squared over 2 equals 1/2 natural log squared of x plus c1. And it's great because once you've got it down to u, getting everything back out is just easy breezy because you just plug it right back in, and keep going. From here on, we just multiply everything by 2. We've got y squared equals natural log squared of x. What we can do is we can make it plus c, and we're going to have c equal to 2 times c1. So you want to keep track of where your constants are going, because sometimes if you've got more complicated equations, your constants may not all end up being the same. But if you've got, a c over here being multiplied by 2 and a c over here being multiplied by 3, well, you got to keep that as c. But because we've only got one c here, we can just simplify, since it's a constant being multiplied by another constant. We're just going to make that our own constant. From there on, we got y is going to be equal to plus or minus the square root of natural log squared of x plus c. And that's going to be our general solution. But we're going to want to find a constant solution because we were given a initial value. So I'm going to move over just to the next page, so I've got a little more room to work with. y1 is equal to 2. So I can do this. 2 is going to be equal to plus or minus the square root of the natural log squared of 1 plus c. Natural log squared of 1 is equal to 0. And since we're dealing with a square root here, and this is a positive number on this side, we know that this side is going to be positive. So it's going to be 2 is equal to the square root, we can ignore plus or negative there, 0 plus c. Squaring both sides gives us 4 is equal to plus or minus c. And since c is in this square rooted term here, it's going to have to be positive in order to get out to that side. So again, we can ignore that negative there. We know that c is equal to 4, which means that our particular solution is going to be y of x is equal to square root of natural log squared of x plus 4. And we can check our stuff too, which I actually sort of like to do, is we've got the beautiful visualizations in our courses, and we've got our direction field. The direction field allows you to double check that your solution is actually a valid solution, because the solution you put in doesn't follow the directions of the initial one, then you know that you did something wrong. Maybe it's, you forgot to raise something to a power or whatever, but I like to use these to double check stuff, especially if it's a written assignment. On WebWork, you just see if it's wrong right then and there, and most of the time you have unlimited attempts, but on the quizzes or the written homeworks, you don't know exactly if you got it right until the end, so this is a great way to double check stuff. So we've got our variables in terms of x and y, so we can leave those variables where they are, and it's going to be dy dx equals natural log of x over xy. So we've got natural log of x divided by xy. We can see here too, since we're dealing with the natural log of x, if we want to be able to pay attention to what's going on here, we can zoom in on this right side because we're not even going to be touching the negatives, so we can make the left side of the x-axis equal to 0. And that allows us to see what's going on better with our function. And our general solution, I'm going to leave c here because you don't want to do the particular solution, otherwise you can't really get a range on what's going on. So I asked for the general, so we've got square root of natural log of x squared plus, we're doing c, not 4 here. The nice thing, it gives you a little preview too, so you can see where stuff is, and I feel like that happens a lot with using the raising stuff to a power, is you don't exactly quite know what it's affecting in here, so double checking this visual too. I've had that happen before. We're just looking at it, I go, oh, there's the problem. We see here, we've got nothing in the negatives either, so if we even wanted to zoom in more, because we're dealing with a square root, it can't go negative, we can really narrow in on the actual function by getting rid of the negatives of the y also. We can use a slider to double check c, and we know that our general solution is probably accurate because it follows that nice curve. So there's my U-Substitution. I hope you find this helpful. I'm going to include a link in the description for the video I watched that really made it click for me. That way, if one of you guys is like, I still don't get it, hopefully the thing that helped me will help you. Yeah, every once in a while, dealing with trig stuff or just other more complicated things, is you're not always going to be able to get it right in the first try, so you may have to try it again, and sometimes you just can't do U-Substitution at all, so you'd want to do like integration by parts or something, but I've found that a lot of times this is very helpful, and it's pretty simple too, to be able to just pick an area, work it out, plug it back in, and move on. Hope this helped.